Okay, May, June 2022, paper 2, variant 2. Question 1 actually has been removed because we are no longer required to know about the micrometer screw gauge. Okay, but definitely the micrometer screw gauge was used to measure distance, very small distances. Okay, it has been removed. So this question has been removed, but for your reference, it does measure the distance. A man stands next to a railway track. A train traveling at 40 meters per second takes 2 seconds to pass the man. What is the length? How can I find the length? Basically, I need to find the distance. So distance or speed equals distance over time. Distance equals speed times time. So you have the speed, which is 40 meters per second, and the time, which is 2, which, so 40 times 2 is 80 meters. Question 3, which quantity is equal to acceleration? Acceleration, is it the area under the graph in a distance time graph? No. What is the area under the graph in a speed time graph? Area under the graph in a speed time graph is the distance traveled. This is the distance traveled. Gradient of a distance? No, this is the speed gradient of a speed time graph. Yes, it is the acceleration. Basically, we're finding the slope. Question 4, on the moon, all objects follow the same acceleration. Which statement explains this? Actually, this is a nice question. Which or which answer explains why all of the objects follow the same acceleration on the moon? Why do they follow the same acceleration on the moon? On the moon, all objects have the same weight. Definitely not, because they have different masses. The moon has a smaller gravitational field strength than Earth. This is right. It is right, but it's not the right answer. I'm not asking about this specific answer. It is a right answer, but it's not the right answer. The weight of an object is equally or directly proportional to its mass. Okay, it sounds a lot better. The weight of an object is definitely it's not inversely, it is directly proportional. So should I choose B or C? I said, no, well, it's not B. Why is it not B? I don't care about whether, okay, I don't care about whether the gravitational field strength on the moon is weaker or stronger or whatever on the moon. What I care about is that when they follow the same acceleration, this means that there is a relationship between between the mass and the weight. What do I mean? We know that weight equals mg. We know that weight equals mg. So if I want to find g, which is the gravitational acceleration, it is weight over m. G equals weight over m. So this is constant for any, g would be constant for any mass and its weight on any planet. So for example, on Earth, if you find the weight and the mass of an object, if you divide the weight by the mass for any object, the g would be the same, 9.8 meters per second squared. On the moon, if you have any mass, if you find the mass and you find the weight of this mass, okay, and you divide the weight by the mass, then the g would also be constant on the moon, which is around 1.6 meters per second squared. So this is constant. Okay, that's why we say that it is directly proportional. It doesn't. I don't care whether it's smaller or not on the moon. Question 5. Okay, you have measuring cylinder with 30 centimeters cubed of a liquid. Some more of this liquid is added until the liquid reaches the 50 centimeter mark. The readings on the balance is increased by 30 grams. It is increased by 30 grams. Can I find the density? Okay, so density equals mass over volume. The mass of the added liquid, the mass of the added liquid is what? Is 30 grams. You added 30 grams. Okay, so the volume is 50. No, the volume isn't 50. The new volume is 50. The old volume was 30. What is the added volume? What is the increased volume? 50 minus 30, which is 20. So 30 over 20 is 1.5 grams per centimeter cubed. An object moves at a constant speed in a circular path. Which statement is correct? Resultant force acts outwards from the center. direction of traveling. Resultant force acts on the object towards the center of the circle. I think this is right. I think when you're traveling in a circular motion, you have a centripetal force, which is towards the center of the circle. Towards the center of the circle. Okay, question 7. A beam is pivoted at one end as shown. The beam weighs 6 newtons and has a weight, okay, and the weight acts at 40 centimeters from the pivot. Okay, so the weight acts at 40 centimeters. This is the center of mass or center of weight. A force of 4 newtons is applied to the beam, causing it to balance horizontally. You want to balance this beam. Where's the pivot? The pivot is all the way on the left end. How can I find the balance, or how can I balance this beam? If you have a downward force, then definitely you need an upward force. You need an upward force. So we can cancel out A and B because they're downwards. You need an upward force because for an object to be in equilibrium, you need upward forces to be equal to the downward forces. Okay, so you need an upward force. Should it be to the left or to the right of the pivot? You can use an equation: moment times distance times force times perpendicular distance equals force times perpendicular distance. You can do that, or you can just say, well, if I have a large force which is 6 newtons and I have another smaller force which is 4 newtons, if you have a smaller force, then definitely you need a larger distance to balance out. You need a larger distance for a smaller force. When you decrease the force, you need to increase the distance. So basically, it's an upward force at a distance greater than 40 centimeters, which would be to the right of x. To the right of x, and that's it. If you want to calculate it, it would be 6 times 40. 6 times 40 would be equal to 20 times no, so 40, okay, which would be equal to 4, which is the force, times the distance, okay, the added distance, so you add 20 times 60. So this is 240, which is equal to 240. So the beam is balanced out. Okay. Question 8. What is the resultant force of these two forces? Simply use the Pythagorean theorem. Square root of 4 squared plus 3 squared, which is 5 newtons. If you want to find the distance would be in this direction. 5 newtons in this direction. Question 9. Which statement describes the impulse acting on an object? The impulse is what? Is it the change in kinetic energy? No, it's the change in the momentum. It's the change. Is it the rate of change of force acting on the object? No, it's the change of momentum. Impulse is the change of the momentum of the object. A ball of mass 0.16 kilograms is moving forwards at a speed of 0.5 meters per second. The second ball of mass 0.1 kilogram is stationary. Okay, the first ball strikes the second ball. Second ball moves forward at a speed of 0.5 meters per second. What is the speed of the first ball after the collision? Okay, this is a simple two-body collision. So basically, you need to use the equation m1 u1 plus m2 u2 equals m1 v1 plus a m2 v2. The first ball, which is m1 0.16, 0.16 times the speed, okay, 0.5 times M2U2, second ball mass 0.10, stationary, so U2 is 0. Basically, you can cancel it out. M1 is 0.16 times V1. We do not know the velocity of the ball after the collision. V1 plus M2, which is 0.1, the second ball, times the speed or the velocity forward, which is in the same direction. It's in the same direction. 0.1 times 0.5. Let's solve it. 0.16 times 0.5 is 0.08 equals 0.16 V1 plus 0.05. And then you just subtract, okay, subtract 0.05. So you have 0.03 equals 0.16 V1. You need to divide by 0.16. You need to divide by 0.16. I guess the final answer would be 0.19. Let me use the calculator. Okay. 0.03 divided by 0.16 is, yes, is 0.19 meters per second. Okay. Question 11. A tennis ball is dropped from position 1 and falls vertically onto a hard surface at position 2. Which energy changes have taken place between 1 and 2? Between 1 and 2. At 1, definitely it had gravitational potential energy, so we can cancel out C and D. Then, as this gravitational potential energy, as it's falling downwards, the GPE is turning into, or it's changing into kinetic energy, and then to chemical energy. No, definitely not chemical energy. We don't have any sort of chemical energy store. No, it's actually turning into elastic potential energy or strain potential energy. Question 12. A boy holds onto a bar and pulls himself up until his chin is level with the bar. He raises himself through 40 centimeters in 0.5 seconds. The weight is 500 newtons. What is the average power? What is the average power? How can I find the power? Power equals energy over time. Power equals energy over time. What is the energy? It's the work done over the time. Or basically you can say force times distance moved over time. The force is 500 newtons times the distance 40 centimeters. 40 centimeters. How can I convert? Oh, you have to. You must convert centimeters into meters. You must convert centimeters into meters. So divide by 100, which is 0.4. 500 divided by 0.4 divided by the time, which is 0.5. 0.5. So basically the answer would be 400. Yes, 400 watts. Okay. Diagram shows a deep reservoir formed by a dam. On what does the pressure at X depend? Pressure in water or pressure in liquids depends on three things. Pressure equals rho GH. Okay, pressure equals rho GH. Density, gravitation, acceleration, and the height or the depth. Density of the water is constant. The G on Earth is constant, so it only depends on the depth of the water at X, the depth below the surface. The conditions of a sample of gas change in two stages. Stage 1, increase of temperature at a constant volume. Increase of temperature at a constant volume. Increase of volume with no change. With no change of temperature. Which row shows, or which row about the pressure after each stage is correct? Which row about the pressure after each stage is correct? Stage 1 and stage 2. Pressure in the first stage, does it increase or decrease or does it stay the same? I don't think we have stays the same. As you increase the temperature, the pressure increases. Yes. As you increase the volume, what happens to the pressure? It decreases. They are inversely proportional. They are inversely proportional. Small pollen particles are suspended in water. Okay, when viewed with the microscope, the pollen particles can be seen to be moving around. This is the Brownian motion. The Brownian motion. What causes this movement? Pollen grains are being bombarded by heavier particles of water, or by the lighter particles of water, or the temperature of the water is higher, or the temperature. It doesn't have to do with the temperature. Does not have to do with the temperature. It has to do with the bombardment. But which particles hit which particles? Do the water molecules hit the, or in this question, they are being bombarded by the water molecules. Are the water molecules heavier or are they lighter? Are they heavier or are they lighter? They are, yes, definitely they are lighter. We're talking about water molecules. Every molecule is much smaller than the pollen grain. That's why the pollen grains keep on moving in this random zigzag motion. Question 16 has been cancelled, it has been removed. block of lead of mass 500 grams. Latent heat fusion. This has been removed as well. Latent heat has been removed from the syllabus. Question 18. What is the name of the effect by which the water forms? Definitely this is condensation. Why does the water form? Because due to the condensation. Question 19. One end of the copper bar is heated to a high temperature. Which mechanism is responsible for the transfer of thermal energy to the other end of the copper? Definitely this is conduction. So the lattice of vibration of copper ions only, is it conduction lattice vibration only? No, this is copper. This is a copper, which is a metal, meaning that you have also energy. You have electrons, free moving electrons. You have free moving electrons. Question 24 cubic copper containers are filled with water. The surfaces of all of the containers are painted black. Two of the containers have sides with 20 and two have sides with 40. Okay, which container radiates at the lowest rate? At the lowest rate. To decrease the rate of emission, you need to decrease the temperature and you need to decrease the surface area. Okay, so you need to decrease the temperature and the surface area. Which row is correct? The amplitude, maximum displacement, so it's 1. The wavelength, it is 8. Yes, it is 8. So B. Question 22. What is the speed of the wave? Okay, that's a nice question. The water wave has a frequency of 4 hertz, and then you have 3 centimeters and 36 centimeters. How can I find the frequency? Sorry, how can I find the speed? Speed equals wavelength times frequency. Do I have the wavelength? It's 36, isn't it? No, it's not. 36 is the distance of how many waves? 1, 2, 3. So you have 3 waves. So you need to divide this by 3, which is 12 centimeters. This is the wavelength. 12 times the frequency is 4 hertz. Should you convert 12 centimeters into meters? Yes, you should. But for this question, it's not, you don't have to. Why? Because all of the answers are in centimeters per second. All of the answers are in centimeters per second. So 12 times 4 is 48 centimeters per second. But definitely, if this was a paper 4 question, for example, you would have needed to convert it into meters per second, which is the SI unit. Question 22. Objects are placed on line XY. Which objects give rise to images that can be seen at E? Okay, nice question. Which objects can be seen at E? So E, you have a mirror, you have reflection. Okay, you have a reflection. How can I find the images? Can I see, for example, can I see R? Can I see S? Can I see Q, T, P, U? How can I find it? First of all, you need to draw, for example, a line from E to the mirror. Okay, it's a straight line from E to the mirror using your ruler. So it will hit this point. Okay, and then again at this point. And from these lines, from these incident rays, you can draw normal lines and then draw the reflected rays. You can draw the reflected rays. You'd find that the reflected rays would just cross T, for example, and on the other side, the reflected ray would just cross Q. Would just cross Q and T. So basically, you can see Q, R, S, and T, but you cannot see P or U. Q, R, S, and T. Okay. An object is placed in front of a converging lens of focal length 15 centimeters. Which row describes the image of the object? Okay, so you have the focal length is 15 centimeters. This is the lens, and F is at 15 centimeters. F is at 15 centimeters. Let's check it out. If the object was at a distance of 40 centimeters, so F is at 15, you have 2F at 30. You have 2F at what? at 30, and let's check out. If I have the object at 40 centimeters, the nature of the image would be real upright. You can never have an object which is real or an image which is real and upright. Real images are always inverted. Virtual images are always upright. Real images inverted and diminished. Let's check it out. If it's at 20, okay, it could be real and it could be inverted. At 20 centimeters, so basically it's at this position between 2F and F, between 2 and F, 2F and F. If the object is at this distance, then the image would be enlarged. The image would be enlarged, not diminished. The image would definitely be enlarged. If the object was quite far away, at a distance much larger than 2F, in this case much larger than 30 centimeters, then the image would be diminished. If it was exactly on 2F at a distance of 30 centimeters, the image would be the same size. If it was at a distance between 2F and F, the image would be enlarged. So that's why this answer is wrong. This should be enlarged. Okay. D would be the only correct answer. Why? Because the distance is less than F. Okay, so the object is at this position. Okay, less than F, it's virtual upright and enlarged. It would appear right behind the object. Okay, what is the speed of light in the plastic material? The speed of light in the plastic material. Can I find it? Yes, I can cancel out C and D. Definitely, I can cancel out C and D because the speed can never increase above the speed of light, which is 3 times 10 to the power of 8. The critical angle is 37. Critical angle is 37. Can I find the speed? Yes, first of all, using the critical angle, I need to find a very important number, which is the refractive index. N equals 1 over sine C. So 1 over sine 37. 1 over sine 37 is what is 1.66. So the refractive index is 1.66. Can I find the speed using this refractive index? Yes, speed inside the medium would be equal to the speed in the air over the refractive index, which is 3 times 10 to the power of 8 over 1.66. 3 times 10 to the power of 8 divided by 1.66 would give you a final answer of 1.8 times 10 to the power of 8 meters per second. Moving on. Which type of waves are produced by a television remote controller? Okay. Um, infrared, yes, infrared. Question 27. Which statement correctly compares radio waves and X-rays? Can I cancel out the wrong answers? Yes, they have the same speed, so A and C are wrong. Radio waves have a longer wavelength or a shorter wavelength? Definitely they have a longer wavelength. A longer wavelength. Question 28. Which row shows the nature of these two objects? The nature of these two objects. So we have Q, P, Q, and R. So it's quite obvious that P and R are magnets. But the question is, what are the poles of these magnets? So P has a north pole on this side, a south pole on this side. R has a north pole on this side and a south pole on this side. Q is obviously is it a copper rod or is it an iron rod? That's another nice question. Should it be a copper rod or should it be an iron rod? The other question you should ask yourself is, has it been magnetized or not? Has it been magnetized or not? It hasn't been magnetized. That's why it is a copper rod. It's a copper rod. So the answer would be B. Hmm. Okay, question 29. Um, it's It's not hard, even though it kind of has been removed. But the answer would be if you have a negative rod right next to metal sphere, then it would kind of attract the positive charges, but to definitely repel the negative charges. It would be B. It would definitely repel the negative charges. A resistor has a potential difference of 12, a current of 6. What is the resistance? R equals V over I. Uh, R equals V over I, so 12 over 0.6, which is 20 ohms. Which equation gives the power dissipated in the resistor? Power equals IV. Question 32. This is a really nice question. This is an excellent question. I actually love this question. Um, you want the current to pass you want the current to always you want the current to always pass from the red terminal to the black terminal. You want the current to always pass from the red to the blue. Okay, let's check it out. Okay. First of all, you have an alternating current, meaning that the current would pass in two directions. The current would pass in two directions. Let's start off with, let's say, D. Let's check it out. If I had D, so this is the positive end. It's an alternating current, meaning that it will change. Let's start off with the positive end from this side. If the current starts moving in this direction, okay, at this point it cannot move to the left, so it will definitely move to the right, okay, and then at this point it kind of has two paths. At this point, it has two ways to go. But let's go on and say, for example, that it wants to move downwards. Okay, I'll just say, for example, it wants to move downwards. Okay, if I'm moving this way, so it will pass from the black terminal to the red terminal, which is kind of opposite of what he wants. He actually wants it to move from the red terminal to the black terminal, so it won't move in this direction. Okay, so what happens if it moves in this direction? Again, at this point, it will have two paths. It could move upwards or it could move in this direction. So it's a wrong answer. D is wrong. What about C? Again, let's start off with positive and negative terminals. It will move in this direction. It's forced to move in this way. Okay. Again, at this point, it can move in two directions. It can move in two directions. It can move this way or it can move in this way. It can move in two directions. So what happens if it moves in the from the red terminal? Okay, it would pass from the red terminal. But the problem is that you have some of the current that is passing from this point. It will pass again from to this point, and then they will both meet at this end. They will pass through this. They will pass through this diode, and then they will meet at this junction, which will keep on moving in loop. They will never end. They will never go back to the power source. This is a very wrong way to set up these diodes in C. It's a very, very intricate way. What about B? What about B? Let's check out B. Again, I have the positive end and the negative end. Let's move in this direction. It is forced at this point to move in this direction. Okay. At this point, it is forced to move downwards. It cannot move to the left. So this is a very nice way to move. Okay, so it's forced to move downwards. It will pass from the black terminal to the red terminal, which is not what we want. Huh? But will it actually go back to the go back to the power source? Let's check it out. At this point, it will go upwards. Okay, it cannot. Okay, in this at this point, it is forced to move downwards and then all the way back to the power source. So it's okay, but it's moving in the opposite direction of what we want. A is the right answer. Let's try it out. So first of all, you have a positive end and a negative end. It's moving in this direction. At this point, it's forced to move in this direction and then downwards from the red terminal. Okay, it's forced to move downwards to the red terminal. It will move from the red to the black upwards, and then at this point, it has to move downwards and then back to the power source. Will it move in the opposite direction? Okay, if I switch the current in the second half of the cycle, so this is the positive end and this is the negative end because it's an alternating current. Let's go on. Let's check it out. I'll go this way at this point, it's forced to move in this direction, and then at this point, it cannot move upwards, it has to move downwards, okay? And then from the red to the black terminal, upwards again, okay? And then passing through this diode and back to the power source. That's why A is the correct answer. A is definitely the correct answer. It's a bit intricate, I know, but it will do. Question 33. The diagram shows a battery connected to a potential divider and to two lamps, P and Q. The slider moves or is moved from X to Y of the resistor. Which row shows the effect of the brightness on each lamp? Which row shows the effect of the brightness at each lamp as it moves from X to Y? Is P changed? Is it affected by the motion of this slider? Definitely not. P is unaffected. P is unaffected. So let's check out Q. So P would be unaffected. As it moves from X to Y, the length increases and therefore the resistance increases, the voltage increases, and the brightness increases. They are all directly proportional as it moves in this direction, as they're moving away from this junction. As the pointer is moving away from the junction, the length increases, the voltage increases, the resistance increases, and therefore the brightness also increases. So it is C. 34 is definitely has been removed from the syllabus. Has been removed from the syllabus. Yeah, question 35. What other movement of the magnet will produce a deflection to the left? As as the magnet is moving towards the tube from end X, as it's moving in this direction, the galvanometer deflects to the left. Okay. What are the poles at X and Y? What are the poles at X and Y while it's moving uh, towards the tube? The poles at X and Y as it's moving towards I said before, towards it will uh, what will happen? Yes, it will be the same. It will be the same. So at this point it will be South Pole and this point will be a North Pole. So basically we want to find which of these situations would also create a South Pole at X and a North Pole at Y. South Pole at X and a North Pole at Y. At A, as it's moving away, what happens to X? It will attract. As it's moving inwards, it repels. As it moves outwards, it attracts. So at X it would be a North Pole and a South Pole. Okay, we do not want this. As it's moving away, again it's attracting. So this is a South Pole and the North Pole. Nope. As it's moving inwards, it repels. So this is a North Pole and the South Pole. Again, wrong. The only correct answer would be D because it's moving outwards. So it attracts. This is a North Pole and this is a South Pole, and thus the um, the galvanometer will deflect to the left. Question 36. Which transformer can give a 240 volt AC input? Okay, can change a 240 into a 15 output. So basically this is a step down transformer. We want to find the ratio VP over VS equals NP over NS. VP over VS, which is 240 divided by 15. What is 240 divided by 15? Let's find it out. It is 16. So basically you want to divide the NP by the NS to find 16. 800 divided by 40 is not 16, it's 20. Okay. Okay. And then 1000 divided by 25, it's not 16 again. Um, well, that's 40, yes. Question C, 2400 divided by 15 is definitely not 16. This is 160. So we have 240 divided by 15 is 60. 2400 divided by 15 is 160. Yes, it is the, if you divide 1200 by 75, it would be 16. Question 37. The diagram shows a current carrying wire in a magnetic field. In which direction is the force acting on the wire? So you'd need to use the Fleming's left-hand rule. Yes, Fleming's left-hand rule, you have the first finger, which is the index finger, it's pointing to the right, and then you have the current on the second finger, which is inwards, okay, into the page, kind of into the page. The force, therefore, on the thumb, the force would be downwards, which is towards the bottom of the page. Fleming's left-hand rule, okay? Left-hand rule. A scientist, only one scientist, was asked to separate the following equations into two categories: nuclear fission and nuclear fusion. Which equations show nuclear fission? Okay, fission, you want to split. Fission, you want to split larger atoms into smaller atoms, but again, you want the equations to be balanced. You want the equations to be balanced. Okay, so let's check them out. For one, you had Pu, polonium, and then which is split into PD and CD, whatever they are. Are they balanced? Okay, let's check it out. 94, is it equal to 46 plus 48? Yes, it is equal to 46 plus 48. Is 239 equal to 112 plus 124? 112 plus 124, but you still have three neutrons. You still have three neutrons. If you add them up, they would be 239, which is correct. Okay, it is correct. So this is nuclear fission, yes. You had helium and helium, which produced helium and hydrogen. Hydrogen, is this nuclear fission? Is it nuclear fission? No, it's not nuclear fission. This is not nuclear fission. Why? Because it didn't split a larger atom into two smaller atoms. You had a nitrogen atom. You added a hydrogen atom, which gave off an oxygen atom. This is wrong. Definitely, this is fusion. You can consider this to be fusion. Question, last one. For uranium, okay, let's balance it out. 92, is it equal to 36 plus 56? 36 plus 56, yes, it is 92. Okay, 235, is it equal to 90 plus 143 plus what? Plus 2. 90 plus 143, okay, so that's 233, plus 2, is that equal to 235? Yes, it is equal to 235, so we have only 1 and 4. 1 and 4. Which radioactive sources used in smoke alarm systems? Smoke alarm systems. Yes, we do use the alpha particles. Why? Because they have the highest ionization effect. A beam of alpha particles and beta particles are incident. Oh, is incident at right angles to an electric field. Which statement about the deflection is correct? Alpha is deflected. Alpha particles deflect and beta do not. No. Deflect in the opposite direction to beta. Yes. Beta deflect, alpha do not deflect. Wrong. Both deflect in the same direction. No. So it is B. Okay.